In this video I will continue to discuss the book An Introduction to Mathematics by Alfred North Whitehead. And in my perspective, if Hegel's logic really is the self-initiated movement of this being that we call God, if this is really an ontotheological logic, and if, as Hegel says, the logic must become the foundation of all truth and all method and all epistemology, it must be the logical ground of everything that which we call true and false, also the standard of reasoning, logic, and truth. And as far as I know, Hegel was not a great admirer of mathematical truths. He considered that mathematics was a dead science. But if Hegel's logic is really the Word of God, the Logos, it must be capable to include within itself the foundation of mathematics, and to include and to explain why Aristotelian classical logic was insufficient to know the truth, but it must find and acknowledge the rationality within classical logic, and also the rationality within modern symbolic logic, and to solve all the problems of mathematics. So I will comment on the chapter 2 by Whitehead, Variables. Mathematics, which I think in ancient Greek means a lesson or knowledge, began when propositions about any things or about some things without specification of definite particular things were proved. And here in the language of Hegel, any in the English language is universal, the Allgemeinheit in German, and some is the particular. And Hegel's logic shows that the universal being is universal and God is universal, must, out of its own inner logic, particularize itself. And the universal in logic is that which remains identical to itself in any of its particular aspects. The human race remains the human race, whether it is Mongoloid, Caucasoid, Negroid, or whatever. A fruit, which is a universal, remains a fruit, whether it's a strawberry, a blueberry, an apple, an orange. So the universal is that which is both apple and orange, without being neither apple nor orange. It has its existence, and from a logical standpoint, existence is that which goes out of the ground, and the universal, which is any mode of being, exists, goes out of itself by particularizing itself. And the particular in logic is that which excludes other particulars from itself. Particular things have in common their universal nature, but they exclude one another because of their particular determinations. So yeah, geometry, which is I think metros or metron is the measure, and geo is the earth. So geometry was the measurement of the earth at first, was the great mathematical science, because if Hegel is right, nature is the mind of God projected in time, space, and the material world. And nature is logical, according to Hegel, and rational, whether from the point of view of der Verstand, which is categorical, classical Kantian thinking, or from the point of view of die Vernunft, which is speculative reason. And if geometry and all the mathematics are contained logically, are founded upon the self-movement of logic, then it would be logical that nature would be geometrical. And the modern physicists, they are amazed and in a state of wonder, and not only the modern, but also the ancient, Pythagoras and Plato and Galileo and Kepler and Newton, to discover the geometrical order of nature. And they wonder, they ask themselves, where does it come from? My answer would be, it comes from God, but in order to be certain that it is the case, then God, as the immanent collective mind, must become conscious of himself as a mathematician and discover whether it really is the mind of God which mathematically ordered nature. So yeah, then we go to algebra, and in algebra, which is the use of letters to try to solve equation and logical mathematical problems, the ideas of any and some, and translated into Hegel language, any means universal and some mean particular, are introduced into algebra by the use of letters, which are symbols, instead of the definite numbers of arithmetic. What is definite is within the realm of being, which has a determinacy or a determination, which is qualitatively and quantitatively determined, and universal and particular are later moments in the logical development. And yeah. So algebra is more abstract than arithmetic, because it removes even the reference to determinate numbers, and it only considers the logical, purely cognitive relationship between quantitative and logical determinations. If in the place of saying that 3 is higher or superior than 2, we generalize. To generalize means to universalize, to transform into, to extract the logical aspect, and say that if x be any number universal, there exists some number particular, or numbers y, such as y is greater than x. So yeah. The technical convenience of the use of letters for the ideas of any number or some number, the creation of symbols, the use of symbols by mathematicians, enables them to facilitate the cognitive grasping and the understanding of mathematical and logical ideas. And I know, as an empirical individual, that chemistry, modern chemistry, made a scientific progress when the language of chemistry, transformed by Lavoisier, which is considered the modern, the first modern chemist, when he used a new language for the science, it enabled the progress of and the systematization and ordering and rationalization of modern chemistry. And even Whitehead later in the book, and if I have the opportunity, I will comment on that, he says that the transformation of logical mathematical ideas through the use of symbols enables the mind to grasp complex ideas much more easily, and to limit the work of the thinking mind. And yeah, and the same goes for Hegel's logic. by elevating oneself into the realm of pure thought, it's not an escape from the world. It is a greater conceptual grasping of what we call the real world, which is just a mirror image of the eternal logical idea. So, yeah, he says that with the rise of algebra and the differential calculus was invented by Newton and Leibniz, which are Leibniz is often considered as the most intelligent individual mind who ever lived. There are debates whether it was Aristotle or Leibniz. Newton is considered the most significant scientific genius ever, the most influential. He was ranked second most influential person ever by Michael Hart in his book The 100. Whether it's the proper ranking, it's not relevant, but it's just that Newton has had a tremendous influence upon all spheres of intellectual and technological and economic and epistemological life. And Leibniz is considered to be the greatest intellect ever. He was, yeah, I don't know if it's true, but yeah. It was not till within the last few years, and we are probably at the early period of the 20th century when the book was supposedly written. It was not till within the last few years that it has been realized, understood, how fundamental any and some are to the very nature of mathematics. Fundamental is a logical determination that we find in the sphere of essence, and the ground, the foundation, the logical foundation contains its consequences, that which is founded by the ground according to the fundamental determinations. And the ground, or the fundamental logical concept, the ground is to the consequence what the universal is to the particular in a more logically developed stage. The fundamentals of the American Constitution contain within their concept all that is deduced from these fundamental ideas, and the consequences are just the logical unfolding of what is fundamentally contained within the first principles. Yeah, instead of talking about the fundamentals or the ground, one could use the word principles. We changed the terminology, but the idea, the concept remains the same. So it was realized that these ideas of any and some, which in Hegel's language is Allgemeinheit und I'm losing my German. Besonderheit, Allgemeinheit und Besonderheit, universality and particularity. For any number x, x plus 2 equals 2 plus x, so the order, which is just used for the mind to simplify the visual aspect, but the order is indifferent. X plus 2 or 2 plus x are the expression of the same logical and mathematical operation. For some number x, x plus 2 equals 3. And here the particular numerical value of x is singular. There is only one answer to this equation, which is x equals 1, because 1 plus 2 equals 3. Hopefully. For some number x, x plus 2 is greater than 3. And here it's a particular because there are many logical values that x can take, which would make the equation verified. For x equals 2, x plus 2 is superior to 3. For x equals 3, x plus 2 is superior to 3. But for x equals 0, then 0 plus 2 is not superior to 3. So here, with these three operations, we have the universal, which means all values, the particular, which is actually a singular, only one answer, and the particular which enables some answers but rejects others. So these are logical determinations. So the easiest, most simple forms of mathematics is founded upon logical determinations. So I know that Bertrand Russell and Whitehead, in their Principia Mathematica, tried to logically found, from the founding fathers of modern logic, they tried to demonstrate that mathematics and logic at the fundamental level were one, but their view was that of a formal logic. And Hegel's view, as far as I know, is that his logic is speculative logic, which is mystical logic. But if Hegel's logic is true, it must contain within itself, like I said earlier, the fundamental truths contained in formal logic and in mathematics. So Hegel's logic must be the foundation of itself and of all what is rational and true and logical, and also of all that is mathematical. And I'm sure that's a bet that the modern mathematicians, those with IQs of 150, 160, and even beyond, they could only understand their own field of expertise by understanding Hegel's logic. And I just stumbled yesterday on a channel by I will be honest, a very attractive, blonde and blue-eyed woman who is very intelligent, who has probably a PhD in physics or mathematics, I don't know, and I will put the link to her channel because she seems to be in a state of bliss because she understood mathematical and physical ideas, and she seems to be joyful, and this is one of the most amazing women I've ever met, if one might speak of a meeting. So I will put the link to her channel, and hopefully mathematical understanding of oneself and of reality can bring bliss and joy, and hopefully he says that thus since x plus 2 equals 2 plus x for any number x, so any means universal, it is true for some number x, some mean particular, and what is true of the universal is true of the particular. But the other way around is not true, because the universal contains less determinations than the particular, and the particular contains determinations which exclude other particulars. So we cannot say that all fruits are oranges. It is not true. It is logically wrong, because apples are fruits and they are not oranges, and they have determinations in applehood and in orangehood which are mutually excluding one another. But it is true to say that all oranges and all apples are fruits. That's basic logic. He says, thus here, as here used, some does not exclude any. So the some, which means the particular, does not exclude the universal. It is the becoming existent, the going out of oneself of the universal. So the particular contains within itself the determinations of the universal, and the universal particularizes itself to give itself an existence. But the particular does not exclude the universal. It realizes the universal, but it excludes other particulars. Like I said, because oranges and apples are equal in the idea of fruithood or fruitness, but in their particular existence they cannot be one, and that's the tragic aspect of human existence, is that men in their finite singular selves are different and mutually excluding one another, but the good aspect is that through a cognitive act, through the work of reason, they can be made to agree with one another, and what is reasonable, not reasonable, what is rational, what is logical, what is true, is equal for all thinking minds. And yeah, the equation x plus 2 equals 3, x is called the unknown. The object of the solution of the equation is the determination of the unknown. And if I spoke like Hegel, I would say that the unknown is not totally unknown, because we can predicate and determine determinations about the unknown. We can say that it exists only in relation to the known. It has the determinacy of being that which is opposed to the known. So we can know something about the unknown. Sometimes it's exhausting to talk like a dialectician, but anyway. Then the consideration of the pairs of numbers x and y, fractional or integral, which satisfy x plus y equals 1, involves the idea of two correlated variables, x and y. And here we are in a relationship of proportion. If we have the equation x plus y equal 1, the more x increases, quantitative determination, the more y decreases. They are in a reciprocal conceptual unity with one another. If x equals 0.8, then y equals 0.2. And if x equals 0.5, y equals 0.5, and they are balanced, and they are 1. The aggregate of pairs of numbers which are bound together by some fixed relation, by the relation x plus y equals 1. This is a logical relation. It is not in general true that when a pair of terms satisfies some fixed relation, if one of the terms is given, the other is also definitely determined. The example is y square 2, y multiplied by itself, I don't know how you say it in English, y square 2 equals x. If x equals 4, y can be minus 2 or plus 2. It can be positive 2 or negative 2. So here the numerical value of y is given. It is 2, but the logical determination can be positive or negative, because minus 2 multiplied by minus 2 equals 4, and positive 2 multiplied by positive 2 equals 4 also. So for any positive value of x, there are alternative values for y, and these alternatives are logically determined by the conceptual relationship of the positive and the negative. X plus y equals 1. If either x or y be greater than 1, there is no positive number which the other can assume so as to satisfy the relation. Thus the field, the logical extension, of the relation for x is restricted to numbers less than 1, and similarly for the field open to y. So if x plus y equals 1, and x equals 2, y must equal minus 1, because 2 plus minus 1 equals 1. So if that's a logical relationship again, if x goes out of its boundaries, becomes higher than 1, the right member of the equation, then y must become negative, the negative of x, and they are in a logical relationship with one another. So the most basic mathematics for undergraduate, not undergraduate, how do you call it, junior high school or high school students, not even high school, it's so basic that it's for teenagers, that it can be and should be logically proven why these mathematical relationships that everyone agrees are true, to show the logical structure, the conceptual structure of the truth of these logical and mathematical relationships. He says that the study of the general properties of a relation between pairs of numbers is much facilitated by the use of a diagram, and all algebraic and even arithmetic um, logical relationship can be represented, can be made manifest for the eye in a geometrical form. And diagrams are the geometrical expression of algebraic relationships, which are logical relationships. So logic, through the realm of time and space, can become visible and made manifest to itself. And it's especially important in physics and in sociology and economics, the idea that logical relationships expressed in mathematical correlations are made manifest through diagrams. The bell curve is a geometrical representation of mathematical structures which are applicable to social, economic, and partly sociobiological laws. So Plato knew that the mathematical truths of the universe were made were made visible, and therefore facilitated the intelligibility, the understanding of themselves by being made geometrically manifest in space. Yeah. We have the case of determining the unknown p when v is a known number. And we know about the unknown that it exists, it is in a logical unity with the known, and the unknown can be known partly by saying that we know that it is unknown. That's what Slavoj Zizek, in his famous declaration about whatever American leader, there are known knowns, there are known unknowns, there are unknown knowns, and there are unknown unknowns. So that's Hegelian dialectics gone partly insane. So yeah, logic creates, I don't know if it's the proper term, logic deduces mathematics, and mathematics in the realm of nature, which is the world of time and space, can give itself a sensuous presence through figures, diagrams, and yeah, that's all for now. So I'm just planting the seed, and hopefully one day the mathematicians, people who are much more knowledgeable as I am as an individual, will understand their own science through the mediation of Hegel's logic, and they will be able to assert whether or not Hegel's logic is the foundation of all mathematical truths. And if Hegel's logic really is the mind of God, God must be the how should I explain this? He must be the guarantor, to give the guarantee that mathematics are true and explain why they are true. And yeah.